hope you're keeping well. Today we're going to look at solving some basic differential equations. To solve a differential equation in terms of x and y, all we have to do is get all the x's on one side and all the y's on the other side. But note that this includes the dx and the dy. Now basically you can't integrate a function of x with respect to any other letter than x, and that goes for any other variables we might choose as well. We shall be considering 3 examples I have personally chosen for us. No need to thank me. This is example 1. dy by dx equals cos squared x cos squared y. So as we said, we need to get all the x's on one side, all the y's on the other, including the dx and the dy. In this case, that means dividing by cos squared y and multiplying by dx. But 1 over cos squared y is the same as sec squared y, which we already know how to integrate. The integral of sec squared y with respect to y is tan y. And the integral of cos squared x is a half x plus a quarter sine 2x. See the trigonometric integrals video for further information on both of those. And don't forget, plus c. Time for example 2. dy by dx equals xy minus 12 minus 6y plus 2x. As before, we still have our desired goal of getting all the x's on the same side and all the y's on the same side. Adding and subtracting terms is not going to work, I'm afraid. The only way we can achieve our goal is by multiplying and dividing, which we can do if we factorise first. Factorisation might look a bit daunting, but it's actually pretty easy here when we appreciate that it must be possible. The xy must be split up, with x in one bracket and y in the other. The 2 needs to go with the y, so we can times it by x, and so on. You get the picture. We can now divide by y plus 2 and times by dx. The integral of 1 over y plus 2 is ln y plus 2, and the integral of x minus 6 is just half x squared minus 6x, plus c of course. And so we come to our third and final example, example 3. dy by dx equals cot x cot y. Just like in example 1, we can straight away get all the y's on the left by dividing by the y function, get all the x's on the right by multiplying by dx. Remember that 1 over cot y is just tan y. So we have the integral of tan y dy equals the integral of cot x dx. The integral of tan y with respect to y is ln sec y, and the integral of cot x is ln sin x. And again, I implore you to see the trigonometric integrals video to remind you why this is. Now, if it wasn't for the plus c, we could cancel the logarithms. But if we're a little sneaky, we still can. Write c as ln a, i.e. just the logarithm of a different constant, and then use the first rule of logs, that one about when logarithms are added we can multiply, so that ln sin x plus ln a equals ln a sin x. And now we cancel those pesky logarithms and leave ourselves with sec y equals a sin x. Thank you very much for watching.